Hey everyone, Jason from OddAudio here. I have a bit of an odd one to show, and it's just something that I noticed when I tried an experiment in one of my designs, and it's something that a lot of people don't talk about. So, what I'm going to show is, as you can see here, this is actually a power supply, entirely tube based. It is a tube rectifier, tube gas regulator that I'm using as references. These are basically like Zener diodes in tube form. You can think of them that way. And then it's regulated with an EL34 as a pass element. So this is a voltage regulator and a tube rectifier, and this is feeding my preamp design. And I've built two of these. I have another one for my phono stage. But I had the bright idea of, wow, these xenon diode rectifier tubes are really cool. This is actually a rectifier. It's essentially two diodes in one. And like, as you can see the plasma in it. It looks super cool. They're kind of weird. They're directly heated cathodes, and you have to kind of make some compromises to design around them, but they're just really neat. I thought, oh yeah, I got to build a power supply around one of those. Well, I built two of them. The other one was for my phono stage. There's a big problem though, and this is what they don't talk about. And this applies to not only xenon tubes, but also mercury tubes, which you'll see that some people kind of nerd out over. So mercury vapor rectifier tubes, they are obnoxiously noisy. And this is fine for a line stage preamp like I have here. I can regulate and clean this up enough that it's not a problem. But if I connect this power supply to my phono stage, it's just, you hear everything, and I'll show you exactly what you're going to hear. This is a Mr. Carlson's Lab Super Probe, and I will switch it on. So it's extremely sensitive. It'll pick up, like if I have audio running, I can just hold this up to one of the tubes and you'll hear the audio through the tube. So very, very sensitive. So first I'm going to put it on the EL34, which is running on AC heater voltage. Okay, so you can hear the AC voltage there. It's like a slight buzz, right? That's why you really don't want to run a gas regulator in an audio circuit. The things just radiate noise like crazy. And yeah, so they look cool, but and they can theoretically handle really high current, like especially these xenon tubes. You could run a really stout power amp off of one of these. These can do up to an amp at really high voltage, which is like crazy for a tube rectifier. But there's a reason why you don't want to use them in a sensitive audio circuit like a preamp, or really anything. I mean, that level of noise is getting through anyway. It just may not be audible, but there's a noise floor there that you got to deal with. And fun fact, these types of tubes were used in aircraft. These are actually Joint Army-Navy surplus tubes that I got brand new. And they had that exact same problem, and it was so bad that it would actually interfere with control and radio systems. So they learned that back in the 50s when they were doing aircraft, trying to run them off of tube regulated DC power supplies for turrets and stuff, and that how much those would interfere with the other electronic systems in the aircraft. And we kind of forgot about that. And then all these people just rediscovered these tubes and thought, wow, that's super cool. I can have like this really crazy glowing, awesome gas tube as my rectifier. And it's like, I'm here to tell you, you really don't. And it's not just the noise. It's also this type of tube. You cannot couple it with a capacitor, meaning that it would go straight into a capacitor, because they cannot handle that kind of ripple current. So you need to actually do a choke input, which is what I have in this design, meaning you have an inductor, then you go into your capacitors, and that has its own set of challenges and a much lower output voltage than if you were running it straight into a cap. So, worth it? Absolutely not. Do not recommend. But hey, it looks really cool.